How to read a fan performance curve to pick a fan. A fan curve is not a picture of every place a fan can run. It is a map, and your system chooses one address on that map. If you buy from the maximum airflow number, you are reading the edge of the map where pressure is near zero, not the point your duct, filter, coil, or machine actually needs. Start with the axes. Airflow is normally on the horizontal axis. Fan static pressure or fan total pressure is on the vertical axis. Those pressure definitions are not interchangeable, so match the curve to the pressure in your specification. Also confirm the test speed, air density, inlet and outlet arrangement, and whether power means shaft power, motor input, or complete electrical input. Now define the duty before looking at models. In this illustrative example, the requirement is 5,000 cubic meters per hour at 600 pascals. That pair flow plus pressure is the duty point. A flow number by itself cannot select a fan. The descending line is the fan pressure curve. The rising line is the system curve, the resistance of ducts, fittings, filters, coils, grills, and other components as flow changes. The installed operating point is where those two curves intersect. The fan does not simply stay at a point we draw. If a filter loads or a damper closes, the system curve becomes steeper and the operating point moves toward lower flow and higher pressure. At the operating airflow, read vertically through every layer of the data sheet. First, confirm pressure. Then read absorbed power so the motor and electrical supply have real margin. Check efficiency at that point, not only the peak efficiency printed in a headline. Check sound data at the same speed in duty. Finally, confirm speed, current, temperature, and control limits. When comparing candidates, place the same duty point on every curve. Candidate A cannot reach the required pressure. Candidate C reaches it only near the left-hand, unstable part of its curve and would likely need heavy throttling. Candidate B crosses the system curve inside a useful, efficient operating region. The physically largest fan is not automatically the best selection. For many centrifugal fans, operation near or left of the pressure peak deserves special review because flow can become unstable. Far to the right, near free delivery, pressure capability and efficiency can fall. Do not apply one universal percentage rule, use the manufacturer's permitted operating region for that exact fan and speed. Variable speed adds a family of curves. For the same fan under appropriate similarity conditions, airflow changes approximately with speed, pressure with speed squared, and power with speed cubed. These fan laws are powerful for screening, but controller limits, motor heating, air density, and the real system curve still define the usable envelope. And remember, a laboratory curve belongs to a stated test arrangement. A tight inlet elbow, blocked intake, poor discharge clearance, dirty filter, or downstream obstruction can add system effect and move installed performance away from the catalog expectation. That is why the test boundary and the product nameplate are not enough by themselves. Here is the 5-minute selection workflow. 1. Write the required airflow, pressure definition, density, and worst-case system condition. 2. Draw or calculate the system curve. 3. Overlay the fan and available speed curves. 4. At every important operating point, read pressure, power, efficiency, sound, and limits. 5. Verify installation geometry, electrical and controlled compatibility, and commissioning measurements. So, how do you pick a fan from a performance curve? Define the duty, find the fan and system intersection, read every performance layer at that same airflow, and reject any option outside its stable, efficient, and allowable envelope. For an engineering review, prepare the duty points, pressure definition, air condition, installation sketch, voltage, and control method. That information turns a curve into a defensible fan selection.